All right, I'm going to show you how to prepare 1x TAE buffer. And so for that, I have a math equation that you're going to need to learn how to use. It's a very simple equation. It's called a dilution. And if you think about Kool-Aid, if you've ever seen Kool-Aid, it's red, it's dark red, and then when you add more water, it gets lighter. Well, we're going to do the same thing, except that our chemical is colorless, and so we can't see it get less concentrated. And so we're going to dilute it to the proper concentration needed for preparing an agarose gel, as well as this concentration can also be used in your electrophoresis chamber when you run the gels. Okay. So to prepare buffer for making gels, I'm going to be preparing TAE, which is a buffer, and we want to prepare 1x to use to prepare the gels and also to use in the electrophoresis chambers. Okay. And so the equation we're going to use is C1V1 equals C2V2. Okay. My starting concentration of my buffer is 50x. Okay. And so we're going to go ahead and again, my starting concentration is 50x. My final concentration that I want to use is 1x. Okay. And then my volumes, okay. V1, I don't know that one. That's the one we're going to be solving for. We're trying to find out how much of the initial concentration to use. And then volume 2, I'm going to be preparing 500 milliliters. Okay, so we're just going to go ahead and plug all these numbers directly into our equation. And again, this is called a dilution, just like when you make Kool-Aid. So 50x V1 equals 1x times 500 milliliters. Again, you want to make sure you keep all those units on there. You don't want your students to drop the units and come up with the wrong answer or be using the wrong piece of equipment to measure. So we're going to go ahead and do all this math just like Algebra 1 in high school. And we're going to come up with 500x mLs on this side. Okay. And so we're going to go ahead and divide both sides by 50x. Okay. And you can see here that my 50x will cancel on this side, and then this side I'm going to be canceling out my x's to leave my answer in milliliters. And so 50 into 500, the answer is going to be 10 milliliters. We'll be using 10 milliliters of our stock concentrated TAE buffer, and then 490 milliliters of distilled water to prepare 500 milliliters of 1x TAE. All right, so now you've seen the math for how to prepare the TAE solution, and we're going to go ahead and dilute some. Again, we're going to be making 500 milliliters. 500 milliliters is about enough to fill 2 electrophoresis chambers or to prepare a couple of gels and fill 1 electrophoresis chamber. You can see from the math it's not a hard math equation, and also it's also not a hard skills protocol either. And so this is something that you can train your students to do for you, and so in the future you won't have to make as much buffer or dilute as much buffer. So we're going to go ahead and measure out our 10 milliliters of our concentrated buffer. Okay. Remember, you want to always check at eye level. So I'm going to go ahead and pour in my 10 mils, and then I'll check it. Okay, now I've overfilled this. You don't want to dump it back into the bottle, and I keep a liquid waste beaker handy, so if I overfill, I can dump some out. Okay, I'm going to go ahead and recheck that. Okay, 10 mils right with the meniscus on the line. I'm going to go ahead and dump this into my larger graduated cylinder, and then use this big guy to fill up the rest with my distilled water. Okay, again, I'm going to just fill this up to 500, which is going to be about 490 milliliters of distilled water. Okay, and as you get close to your full mark, you want to slow down so you don't overfill. Okay, and again, there's 500 with the meniscus right on the line. I'm going to go ahead and pour this off into a flask that I can use later as I prepare my gels or as I fill up my electrophoresis chambers. Okay, and the action of pouring it will help to mix that even further. Okay, so there you go. There's 1x TAE buffer that you're going to use in your gels with your students. Whether you make them or whether your students make them, you have to make sure that you use buffer and not water.